Okay, I think today's video it will gonna take a little bit more time because it's photometry and photometry. I know you guys already read about photometry in plus two, but I think it's important and we have to look at it as a optometric point of view because measurement of light is central important when we're doing all the tests and when we're trying to do retinogram and all the uh, electrical activity in eyes. So let's see. With radiometry, we measure electromagnetic radiation at all wavelengths beyond the infrared and ultraviolet without being concerned about its relation to the vision. But in case of photometry, we only deal with the visible part of electromagnetic spectrum, which is roughly, we think roughly 380 to 760 nanometer, isn't it? And because they stimulate vision. So using physical term, which is radiometry or actinometry, but when concerning with vision, we always talk about photometry and chromatometry. Chromatometry means it's basically color, measurement of color, but that's not our concern. We only talk about radiometry and photometry. If in terms of radiation is this unit, or in terms of photometry, especially when talking about visible part of the electromagnetic wavelength. Okay, so photometry converts the value of light stimulus to value that is compatible with the way human eye perceive, isn't it? It's a perception. It's developing perception. Photometry means the visible wavelength measurement. Chromatometry reduces the light stimulus spectrum, distribute three values that describes the effect of three different eye photoreceptors: short, medium, and long. But we're not going to talk about chromatometry. So radiometry quantifies the radiation across electromagnetic spectrum, whereas photometry quantifies radiation of visible portion of spectrum. Radiometry employs physical constant, whereas photometry weighted to the human eye's response. That's the biggest difference between radiometry and photometry. Okay. Before learning about radiometry and photometry, we have to understand what is angle. See, first you understand what is angle. Angle is a dimensionless unit, dimensionless parameter, because though angle has degrees or radian, but actually angle do not have any dimension, because if you want to express the angle, let's take example, this is circle, and from this radius, this arc A to B, what is the angle between, see, basically angle formation between two radius and one arc, that is A to B, isn't it? To describe this, you must divide it from the R, and then you get angle, isn't it? That's a simple concept. So angle is this. So whenever you are trying to explain what is 1 radian, then what do you tell 1 radian means? 1 radian means if this is R, if this is R, and if this arc A and B equals to R, isn't it? The above A and B equals to R, then the angle here forms is A and B arc divided by R. A and B is R, A to B R, and R divided by, which is 1. And that's how we get 1 radian. I'm not talking about 1 degree. Okay, so that's how we talk about 1 radian, isn't it? So it's very simple. You must understand what do you mean by 1 radian, and you must understand what do you mean by 1 degree, and you must understand how these things form. Let's take an example. So see, if I'm just going to show you calculation, if this is angle, if A and B, and this is the angle theta, from this R is constant, then we must know the theta angle is AB arc divided by R. Let's do the integration. Okay, 0 to infinity and 0 to infinity. In this case, so let's suppose you move B from all the way to again A. Okay, and AB here all the way through A to B. Okay, total 360 degrees. Then what happens here is to infinity A to B, because you cannot do integration with R is always constant. So all the way, what is the parameter formula? 2 pi R divided by R, isn't it? That's why whenever you move all the way circle, it has total degree of angle is 2 pi at the center, isn't it? That's the equation in case of, if it is a circle, isn't it? So that's why in the center of the circle you'll always find 2 pi radiant, 2 pi radiant angle. Okay, that is what the concept is. So if 360 degree is a circle is divided in 360 stroke, then one stroke is known as 1 degree. And 1 degree, if you divide 1 degree into 60 parts, then one part is known as 1 minute. And if 1 minute is divided 60 times, then one part known as 1 arc second. So 1 degree divided 60 times, it means 1 minute arc. And 1 minute arc divided 60 times, it means 1 second arc. And it is very useful in case of orthoptics. So you will measure orthoptics 40 seconds of arc, hysteresis, and all these things are angle. Okay. So another thing you must understand is what happens if 1 degree converted to radiant. Okay, 1 radiant is converted to degree and to arc minute. So you have to convert these things so quickly to each other, which is very useful for calculations. And let's talk about solid angle. What happens to solid angle? What is solid angle? Solid angle basically means, just remember one football and just center of the football. If you just, this is the picture. If this is the earth, if you think this is the surface of something and the radius of the earth, if you see from the radius to that particular surface, what is the angle made at that surface, which angle is 3D angle, not 2D angle. This is not circle, this is a earth. It's, you can see this is pyramid, and if pyramid, the tip of the pyramid make a solid angle, which is solid angle means 3D angle. So let me explain in another way. See, if this is literally earth and the center of the earth, and then you play a to b some area, because we're talking about area. And when we are talking about solid angle, definitely it is ab divided by r square. Why r square? Because we know ab is area, that's why r square. So it's simply that the area divided by r square, radius square. That's why solid angle is. So you must understand, you must learn solid angle. But solid angle we call it as a steradian, not a radian. Okay. So this unit is also important when we are talking about photometry. So what is the difference between 1 radian and 1 steradian? 1 radian is definitely 2D angle. It's an angle which epicenter to the circle and tending to arc or equal to radius. I have told you that, isn't it? If this is r, this is r, and this arc is also r. In this case, the angle is 1 radian. So, and solid angle, 1 steradian means, sorry, when epicenter to the sphere and surface area equals to, so this is radius r and the radius r, and the whole area is r square. At that point, the angle made at the 3D angle made at the center of that earth or center of that sphere is 1 steradian. Okay. So here I want to discuss the fundamental quantities of radiometry and the photometry. Let's give few times for this presentation. In case of radiant power, at the same time, if fundamental of photometric quantity, it's a luminous power. What is the difference between radiant power and luminous power? See, power means it's always a watt, isn't it? But in case of a photometry, we call it as a lumen. In case of radiometry, radiant flux is amount of energy per time, isn't it? Radiant energy. In case of uh, photometry, it's amount of luminous energy per time. But same thing, okay? Okay, so we are comparing radiometry with the photometry. The second thing is power per unit surface area. Okay, that in radiometry it's called irradiance, and in photometry it's called illuminance. Okay, power per unit surface area, which means basically power divided by surface area. So watt per meter square is the unit of, in case of radiometry. In here it's called lux, which is basically lumen per meter square. Okay, the third unit is power per unit solid angle, which is called radiant intensity, and what is watt divided by steradian. And in photometry is power per unit solid angle is luminous intensity. Here is radiant intensity, here it's luminous intensity, and its definitely unit is lumen per steradian, and that unit also called candela, which is very very standard SI unit. Okay, and the last unit is power per unit surface area per solid angle, which is radians. So watt divided by meter square is steradian, and at the same time power per unit surface area per unit emitted solid angle is luminance, and the unit is nit, which is lumen divided by meter square is radian, or another, because lumen divided by its radian is called candela per meter square is basically conversion of the unit. So basic fundamental units in case of radiometry and corresponding photometry is same. Was in photometry we use uh, what radiant power, luminous power unit as a lumen, and then every unit got changes. That's why lumen intensity and irradiance, radiant intensity, radiance. In case of photometry it calls luminance, illuminance, luminous, and luminance. So that's how it's, sometimes we get confused here because terms like similar. So don't confuse, it's just compare one another. Okay, so the study of the measurement of light in terms of visual response it produces, and however it is used in certain non-visual instrument like photoelectric and light meter too. So advantage of photometry is to reduce the eye strain, because when we know the standard value of certain work condition and certain instrument, it will reduce the eye strain and fewer accident in better working condition. That's why we need in working condition photometric value, greater the production of manufactured good, improved laser facilities, and better working conditions. So photometry is helpful in this condition. So visual sensitivity, the eye is not equally sensitive to a different color. Okay, so maximum sensitivity in photometry, photopic condition is 555, and in scopic condition 507 nanometer, as we know it, isn't it? The shift from photopic to scotopic is known as frequency shift effect. We know it. So it's just this graph we can see in a visual perception book, isn't it? So the maximum sensitivity in scotopic is 507, maximum sensitivity in photopic is 555. So photometry is essential science. In comparison, photometric quantities such as intensity and illumination, all the photometric quantities are related to only necessary sets of quantities as a standard source, and primary source for light is based on the concept of black body radiation, but I'm not going. So let's discuss one by one about the unit. So luminance flux, it's simple. Flux means flow, the total light power produced and transferred by the source, isn't it? So see, total light power means the rate of flow of the energy in lumen. See, if you buy one tungsten bulb, suppose example, and it's emit light. Suppose tungsten block from the shop means 50 watt. So it doesn't mean 50 watt converts into light. It means maybe 10 watt converted to visible light and 40 watt in heat, isn't it? That's why a lot of poultry farm use tungsten. Total energy consumption is 50 watt, 10 watt in a production of light, visible light sensitive to eye, and other maybe other wavelength or radiation, isn't it? So that's important point you must understand. So depending on the luminous. So radiometry is radiant flux, its unit is watt. In photometry, radiant flux its unit is lumen. So it's central important to understand. Unit lumen, okay? So isotopic lumen means 680 scotopic lumens per watt, 555. It's necessary to evaluate the luminous flux source in wavelength, particular wavelength. So basically, what particular wavelength create the luminous efficacy? Efficacy, because efficacy is maximum in 555, isn't it? That's efficacy is 100%. It's maximum. As you go above or below the wavelength, the efficacy reduces. This graph shows you. So luminous intensity, another unit, refers to distance of given direction and flux emitted per unit solid angle. So you must understand per unit solid angle. So luminous flux emitted per unit solid angle means, uh, as I have discussed, solid angle is a radian. What is the concept? Concept is the center and This is the area, isn't it? So center of the earth and certain area. So basic formula is area divided by r square. So steradian. So basically unit is candela or lumen per steradian. The lumen is one candela. What is the one candela? One candela means the intensity of the source emitted one lumen unit into the one steradian space. Okay, at directionally. You see, if one lumen emitted at 1 steradian, this angle should be 1 steradian, then it is called 1 candela. So it's fundamental unit in the photometry. Okay, so illuminance power surface, power that falls on the surface. Illuminance is power that falls on the surface. So flux for per unit area. So basically amount of light, which is lumen divided by surface area meter square. It's very simple. So this is called lux. Okay, so amount of lumen per meter square. So it's simple as hell, and you see a lot of place that lux unit. So typical luminance value, see, it's a night sky and sky with moon and normal light, intense light, overcast sky, sunny day, and direct light. How this change from 10 to the power minus 4 to 10 to the power plus 4, isn't it? So huge variation between these two, and our eye can handle that, isn't it? So our eye has many properties to handle and adjust the photometric quantity and adapt it. So basically flux by area is lux. So you must understand the unit of lux. So this is the recommended illumination value and given by what? See, so Engineering Society of North America. So this is how you can see, isn't it? This restroom must have 100 to 200 illumination. For example, classroom should have almost 500. Eye surgeries areas should have 1000 to 2000 lux as a standard. So law of photometry, we have two laws, basically two fundamental laws. First law is illuminance at a point of surface is inversely proportional to square of the distance. That's why we call inverse square law, isn't it? It's very simple. As you move from, if r is greater than 2r, this 3r and 4r, as distance grows, illumination decreases in is inverse. It's simple. I know it's we have already discussed in class 12. The second state law is the normal illuminated surface is at angle theta, then direction incident light. The illumination is proportional to cosine of theta. It's called cosine law, isn't it? So it is the one. It is the thing that's why in 12 p.m. a.m. sorry 12 p.m. Uh, we feel sunlight is hot, and in dawn sunlight is not that hot because the radiant intensity or luminous intensity observed an ideal diffuse surface radiators is proportional to the cosine of the angle, isn't it? And we know that if cos theta cos 0 means 1, and whenever sun goes at the horizon, then cos 90 is equal to 0. So that's why sun in our head is more hotter. So basically this is same thing. Just pause the video and see. Only one thing I want to express is Trolan. What is Trolan? It's a retinal illumination phi. So it's a unit of retinal illumination. And what is Trolan? The one Trolan is the retinal illuminance when effective in trans pupil should 1 mm square and view the surface. So patients should view the surface of luminance of 1 candela per meter square in this line of sight direct. In that condition, retina has one true length of illumination. You will see that unit a lot in low vision books. Okay, so basically there are a lot of things we are talking about, like reflection, and we have to already talk about the Fresnel's rule law. So luminance quantifies the amount of light coming off the surface. Illuminance going to the surface, luminance coming off the surface. Okay, so this is piece and another thing. The unit is candela per meter square. A candela means lumen per steradian, and meter square is always here, isn't it? That's the unit. Okay, you can convert this unit to. So luminance is reflectance and candela per meter square, which another name Lambert and apostable. One apostable is the one luminance reflex square, and this you can see this apostable unit when you are talking about automated visual field and the environment. Okay, So cosine diffuser, there are surfaces that which show same luminance regardless of angle at which it is measured. That is known as Lambert perfectly diffuse and matte surfaces and close. And you'll see this cosine diffuser in AVF and GVF surfaces are both cosine diffuse surfaces. Okay, so here we see it's when light is going, its a luminous flux is basically all the light that is going out, and luminance intensity is its surface. It's essentially important. So when sunlight throws the light, it's always luminous flux, total lumen unities, and luminous intensity, which is per steradian angle luminous flux. That candela, when it going to unit surface area, it's called illuminance. And reflect, and how light reflects from the surface is luminance, candles per meter square. And when it goes pupil, and the retinal illuminance unit is strolams. Okay, and again, just I want you to stop this video and compare these two units, and you need simply compare these two units, you understand more and more about photometry. Okay, so okay, thank you so much. And the reference I have already told you, the three of my favorite books. Okay, bis dann, tschüss.